F1 and F2 at 0 plus or minus 2, and the length of the major axis is 8. The moment I am told, regardless of how it looks like, if this is the major axis and I'm told that the length is 8, I know that A is 4. 4, 4. Okay, so let's picture let's picture the foci first. Positive 2, negative 2, 0, positive 2, 0, negative 2. So this is F1 and this is F2. Obviously, this must be the major axis because that's where the foci are. That's very clear. So therefore, if A is 4, meaning this is positive 4 and this is negative 4. Centered at the origin, all I need to determine to find the equation is I have to find B. I don't know how wide the ellipse is. In other words, how big is the minor axis? What is the length of the minor axis? Half of it will be B. Okay, but I also know that B squared equals A squared minus C squared. And I have A, which is 4, so this is 16. I have C, which is 2, so that's minus 4. And look at that again, that's square root of 12. Which was what? What is the square root of 12? 3.5 roughly. Okay, so 1, 2, 3.5, 1, 2, 3.5. And here is the ellipse. They want us to graph it or not, but we need to write the equation. So x squared over plus y squared over must equal 1. So notice that since it's a vertical axis, it has the major axis is vertical, then under y squared, I have to have the larger number of the two. So A is 4, I have to square that, and that's 16. And then B squared is 12. And this is the equation of the ellipse that has the given foci and major axis 8 units. Any questions? Any questions? So this is again negative the square root of 12 comma 0, and this is the square root of 12 comma 0, or 2 the square root of 3 comma 0, and the negative 2 the square root of 3 comma 0. Do we feel a little bit better about the ellipse? Can we move on to the ones that are not centered at the origin?
Yes.
Perfect. So let's look at these two examples. Write an equation for each ellipse. And as you see, they do not have the center at the origin. Which one? 40 or 42? Of course, the equation is x minus h, everything squared over a squared, exactly y minus k, everything squared over b squared equals 1. Or these reversed if it's on the vertical, if the major axis is vertical. Okay, so which of these two you'd like to work on? 40, 42, please choose.
Can you do 40?
Yes, of course. As you notice, the center is given to us, -1, -1. Can anyone give us A? Can anyone give us B? By looking at the graph. Is the major axis vertical in 40 or horizontal? Major axis is vertical or horizontal?
Vertical?
Yes. Therefore, let's determine A. How much is A? From the graph. The major axis is vertical. So then how big is A?
Would it be 4?
That's the entire major axis. I agree, from -3 to +1. Exactly. So then A squared equals 4. Awesome. What about the B, which is half of the minor axis? How much will that be? How long is B? Anyone, please?
1?
1. So then B squared equals 1. Perfect. That's all we needed. So this has to be, in this case, because it's a vertical major axis, this will be 4, this will be A squared, and this will be B squared. So then x minus h, x plus 1 squared, divided by the smaller of the two. You don't have to write 1, you can just leave it without it, but I'm going to write it again. So this is y plus 1, everything squared, divided by 4, equals 1. And yes, you can rewrite it as x plus 1 squared plus y plus 1 squared over 4 equals 1. This is the equation of the ellipse, centered at -1, 2, with a major axis that is vertical. Yes, sorry.
Could you change your screen, please?
Oh no. Oh, I'm so sorry. Should I repeat all this?
I would, yeah, please.
Yes, of course. Sorry about that. Sorry. So you correctly identified the A equals 2. We have to square it, we get 4. You correctly identified B as being 1. We have to square it, it turns out that it's the same. Because the ellipse has a vertical major axis, this has to be A squared and this has to be B squared. So let me write it here one more time. For the vertical major axis, so it's x minus h, everything squared over b squared plus y minus k squared over a squared equals 1. Therefore, we replaced this by 4 and we replace this by 1. So x plus 1 squared, x minus minus 1, and y minus -1, x plus 1 squared over 1, b squared, and y plus 1 squared over a squared, which is 4, equals 1. And I was saying there is no need to write 1. We don't write like this, right? We don't write something over 1 unless we need to show something, but not, this is the correct and simplified form of the equation of this ellipse that we picked. Is this okay?
Yes.
Perfect, thank you. So let's continue. This needs practice. Okay. Here we're asked to find everything. Analyze each equation, find the center, foci, and vertices of each ellipse. The vertices here are very clear, right? -1, 1. -1, -3. Okay, so this one has a square completed already. This one does not. So this one has an extra step of completing the square. So maybe you want to look at the whole exercise. This is just partial, right? Here we're asked to, we have to complete the square first. We complete the square. We're going to get it into this form. And then we can identify the center, the foci, and the vertices. So that's one. Here's another. Here's another. So let's go for the full situation. 48, you choose 50, you choose 54. Any preference?
48.
48, let's start with 48. Where is 48? I see it. 48, we have x squared plus 3y squared minus 12y plus 9 equals 0. Perfect. So when we analyze this equation, we realize that we have two terms with y, one with y squared and one with y, but we only have one term, which is the x squared in x. So there is nothing I can do to x squared. Done. But here, I cannot complete the square if the leading coefficient is not 1. What should I do to these two terms to have the leading coefficient 1? Well, I cannot change the problem, but I can rearrange it. What would you do to these two terms to have 1 as the leading coefficient for now?
Factor 3 out.
Excellent. So I have y squared minus 12, y, plus, minus, plus 9 equals 0. So these have to be the same, because I cannot add unless I subtract. And the problem is, in the past, when we looked at the previous example, I said it's okay. You either add here and add here. Right. Because the leading coefficient was 1. If the leading coefficient is not 1, I cannot randomly say, I'm going to add here and add here. No, they have to be together, like here. So one more time. Once I factor out a 3, this becomes a new world, so to speak. Can anyone tell us inside here, inside parentheses, what we have to add and subtract to complete this square? And we just had an example like that a few minutes ago.
Wouldn't that 12 turn into -4? Because we factored the 3 out.
Of course. Of course. So 3y squared minus 12. Thank you, thank you. I'm focusing on the next step. No excuses, no excuses. Thank you, thank you, thank you. I would have gotten in trouble later on, but thank you. Yes, of course. I factor out 3 from these two terms. It's 3y squared minus 4y. 3 times y squared is correct, and this times this is correct. My mistake. No excuses. Okay, perfect. Now, what do we add and subtract? And it has to be inside parentheses, not outside. That's not going to work this time because of this. What do we add and subtract to complete the square? Y squared minus 4y.
Would it be +4 -4?
Excellent. And this is 0. But now I will change this into, and be careful, we need parentheses and brackets here. X squared plus 3. And this cannot go away. Plus 9. What do we write here? This squared, these two terms squared, will give us this.
y minus 2.
Very good. Thank you very much. Indeed. Now careful. We are distributing 3 here. Note, do not touch that. And we are distributing 3 here. That's what I was saying. Make sure that you're adding and subtracting inside parentheses here because of the leading coefficient. So then we have x squared plus 3y minus 2 squared. 3 times negative 4 is negative 12 plus 9 equals 0. Negative 12 plus 9 is 3, and it has to be moved to the other side. So x squared plus 3y minus 2 squared equals 3. Next, what do we have to do at this point? Mandatory. We cannot continue without that step. Anyone, please?
Divide by 3.
Of course. Thank you very much. So x squared over 3 plus y minus 2 squared over 1 equals 1. I shouldn't, but I wrote it up there. So x squared over 3 plus y minus 2 squared equals 1. This is bigger than this. So a squared equals 3 and b squared equals 1. Is the major axis vertical or horizontal? I know it's a silly question. And if can anyone identify the center? Can anyone give us the center first? And is it vertical or horizontal, the major axis? Anyone, please? What do you think? Anyone? Major axis vertical or horizontal? Don't be shy, please.
Vertical?
So if the bigger number is under x squared, it has to be horizontal. If the bigger number is under y squared, then it's vertical. Since the bigger number is under x squared, the major axis is horizontal. And a equals the square root of 3. So this is 1.7 something. So 1.7 here, 1.7 here. So the first vertex, v1, negative the square root of 3 comma 0. The second vertex, so this is v1 here, v2. I don't want to put them too close so I can graph. So this is square root of 3, 0. Good. Can anyone identify b? B squared equals 1. So how much is b? 1. I meant to write the center, and I didn't. So we have to start from scratch. The center is 0, 2. I have to start with the center. The center is not the origin in this case. Sorry about that. So the center is 0, 2. 0, 2. This is the center. Now,
Professor, I have a question.
please.
Sorry.
No,
which-
please. It's To me, it's extremely important when students ask.
Where did you get the 2 from for the center? The 0, 2. Where's the 2?
0, 2.
Oh, okay. Thank you.
The same thing with the parabola. So it's the same formula. I think it's on the previous page. Zero, because we don't subtract anything from x, comma 2. 0, 2. Is that okay?
Yes, thank you.
Perfect. Good. So we have to start with the center. I just rushed to graph it. So 0, 2 is the center. Now, we have that this is a horizontal axis, and we want to find the vertices. So indeed, from the center, the square root of 3, so this is correct, but the y-coordinate isn't, because the y-coordinate has to be 2. So 1, 2, 1, 2, 1.7, and 1.7. So this is V1 equals the square root of 3, but the y-coordinate is 2, and V2 is the square root of 3, and the y-coordinate is 2. So this is V1, this is V2, this is the center. Okay, now B, the square root of B, the square root of 1 is 1, so I have 1 unit here, 1 unit here. So this is the B, and this is the B. So I have the graph. They're also asking us to determine the foci. So one more time. I have the vertex on the left, negative the square root of 3 over 2. I have the vertex on the right, the square root of 3 over 2. I have the center, which is 0, 2, 0, 2. Because A is bigger, this number is bigger than this one. It's a horizontal major axis. And we're only asked to determine the foci. That's the last thing that we needed to determine. So we know that b squared equals a squared minus c squared. So this is b squared is 3, c squared is unknown, and b is 1. So c squared equals 2. So c will be the square root of 2. Now the two foci have to be left and right of the center on the horizontal axis, because that's the major axis. The y-coordinate has to be 2. So F1, F2. The y-coordinate must be 2. Now the x-coordinate is negative the square root of 2, positive the square root of 2. Luckily, because the vertex, the center was nicely positioned, just 2 units up from the origin. Okay, how do we feel about this? Do we need another example here? Do we want to look at find the equation of the ellipse given different information?
Yes.
Okay, please choose any that you like. Anyone?
We do 58.
58. In 58 we have foci at 1, 2 and negative 3, 2. Okay, and they are giving us one vertex at negative 4, 2. Perfect. Let me